Introduction: the power beneath our feet. The ground beneath us feels solid, stable, and unshakable. But in reality, the Earth is constantly shifting, moving, and sometimes violently shaking. Earthquakes are one of nature's most powerful and unpredictable forces. They have shaped landscapes, destroyed cities, and altered the course of history. But what exactly causes these massive tremors? How do scientists measure and study them? And is it possible to predict the next big earthquake before disaster strikes? In this video, we'll uncover the fascinating science behind earthquakes, exploring the hidden forces that shape our planet, the technology used to detect seismic activity, and the ways we can prepare for and mitigate their devastating impact. So, let's dive deep into the Earth's crust and uncover the secrets of earthquakes. What causes earthquakes? At first glance, the Earth may seem like a solid, unchanging sphere. But beneath the surface, our planet is alive with motion. The outer layer of the Earth, known as the lithosphere, is broken into massive pieces called tectonic plates. These plates are constantly in motion, drifting on a layer of semi-molten rock known as the asthenosphere. When these tectonic plates interact, they build up stress over time. Eventually, this stress is released in the form of seismic energy, causing the ground to shake and earthquake. There are three main types of tectonic plate interactions that lead to earthquakes. Convergent boundaries: when two plates collide, one is forced beneath the other, creating subduction zones. These zones are responsible for some of the world's most powerful earthquakes, such as the 2011 Tohoku earthquake in Japan. Divergent boundaries: when two plates move apart, magma rises to fill the gap, creating new crust. While these earthquakes are generally weaker, they can still cause significant ground shaking. Transform boundaries: when plates slide past each other horizontally, the friction between them can cause stress to build up. The San Andreas Fault in California is a famous example of this type of plate boundary, responsible for frequent seismic activity. How are earthquakes measured? Earthquakes vary in strength, from barely detectable tremors to devastating events that flatten cities. Scientists use two primary methods to measure their magnitude and intensity. The Richter scale, developed in 1935, this logarithmic scale measures the magnitude of an earthquake based on the amplitude of seismic waves. Each whole number increase represents a 10-fold increase in shaking and roughly 30 times more energy released. The Moment Magnitude Scale (MW). This modern scale provides a more accurate measure of an earthquake's total energy release, especially for larger quakes. It has largely replaced the Richter scale in scientific studies. In addition to magnitude, scientists assess the impact of an earthquake using the modified Mercalli intensity (MMI) scale, which categorizes the severity of shaking based on human perception and structural damage. The role of seismographs and early warning systems. To monitor seismic activity, scientists use seismographs instruments that detect and record ground motion. These devices help map out earthquake-prone regions and study patterns in seismic activity. In recent years, earthquake early warning systems have been developed in countries like Japan, Mexico, and the United States. These systems use a network of seismometers to detect the initial, less destructive P waves of an earthquake and send alerts before the more powerful S waves arrive. While the warning time may only be a few seconds to a minute, this brief window can save lives by allowing people to take cover, trains to slow down, and emergency services to prepare. Can we predict earthquakes? Despite advancements in earthquake detection, accurately predicting when and where the next big quake will strike remains one of the biggest challenges in geophysics. Short-term prediction. Unlike hurricanes or volcanic eruptions, earthquakes do not provide clear warning signs. Scientists have studied foreshocks, strange animal behavior, and even electromagnetic signals, but no reliable method for short-term prediction has been found. Long-term forecasting. While exact predictions are impossible, scientists can estimate the probability of earthquakes in certain regions by studying historical seismic activity and fault line stress accumulation. For example, the San Andreas Fault is overdue for a major quake, leading researchers to warn of a possible big one in the coming decades. The most devastating earthquakes in history. Throughout history, earthquakes have left a trail of destruction, reshaping cities and civilizations. Some of the deadliest and most impactful earthquakes include 1556 Shaanxi earthquake, China, the deadliest earthquake on record with an estimated 830,000 fatalities. Many victims lived in cave dwellings carved into cliffs, which collapsed during the quake. 1906 San Francisco earthquake, USA. A magnitude 7.9 earthquake that triggered massive fires, destroying much of the city and leaving 250,000 people homeless. 2000 for Indian Ocean earthquake and tsunami. A magnitude 9.1 to 9.3 earthquake off the coast of Indonesia triggered a devastating tsunami, killing over 230,000 people across multiple countries. 2011 Tohoku earthquake, Japan. A magnitude 9.1 earthquake that caused a massive tsunami, leading to over 15,000 deaths and the Fukushima nuclear disaster. How can we prepare for earthquakes? While we may not be able to prevent earthquakes, we can take steps to reduce their impact. Earthquake-resistant buildings, modern engineering techniques such as shock absorbers, flexible foundations, and reinforced steel structures can help buildings withstand seismic forces. Emergency preparedness. Having an emergency plan, securing heavy furniture, and keeping an earthquake survival kit with water, food, and first aid supplies can save lives. Community awareness. Educating the public about earthquake safety, evacuation routes, and the drop, cover, and hold-on technique is crucial in minimizing casualties. Conclusion: the unpredictable power of earthquakes. Earthquakes are a reminder of our planet's immense power and unstoppable force that has shaped the Earth for billions of years. While predicting them remains a challenge, our understanding of seismic activity continues to improve, helping us prepare for the inevitable. By studying earthquakes, advancing technology, and implementing safety measures, we can reduce their impact and build a more resilient future. The Earth will continue to shake, but with knowledge and preparation, we can stand strong.